Hello everyone, welcome back to my channel Risk Modeling Hub. Most candidates preparing for credit risk interviews make one big mistake. They jump directly into modeling without understanding their data. And that's exactly where they fail. In this video, I'll help you master one of the most important concepts in credit risk modeling, exploratory data analysis or EDA. Not just definition, but how to think, how to analyze, and how to explain EDA confidently in interviews. And by the end of this video, you'll not only understand the EDA concept deeply, but you'll also be able to answer interview questions with clarity and confidence. And make sure you stay till the end because we'll also see how EDA is applied practically in Python. Let's start with the most basic question. What exactly is EDA? So, EDA or exploratory data analysis is the process of understanding the data before building a model. Here, you understand the data structure, identify patterns if any, and detect the issues. So, EDA or exploratory data analysis is basically the first step we perform after getting the data. In credit risk modeling, we cannot directly jump into building a model. First, we need to understand what kind of data we are working with. So think of EDA as exploring the data. Just like when you open a new dataset, you try to understand what variables are there, what values they contain, and whether the data makes sense or not. So EDA is not just about looking at data, it is about asking the right questions from the data. For example, does income look realistic? Are there missing values? Are some customers more risky than others? So, in credit risk, our ultimate goal is to predict whether a customer will default or not. EDA helps us understand which variables can actually help in predicting that risk. So, EDA converts raw data into meaningful understanding. Now, let's understand why EDA is important in credit risk. Bank give loans to customers. Some customers repay and some default. Now the question is, how do you identify who is risky? The answer is, this is where the EDA plays a very important role. In credit risk modeling, we are not just working with data, we are dealing with money, loans, and risk. So identify the risky customers, as EDA helps us discover patterns in the data. For example, customers with low income may default more, and customers with high credit utilization may be riskier. These patterns come from EDA, not from the model. Next is ensuring the data quality. That is, if the data is wrong, the model will also be wrong. Here we explain the missing values, any incorrect entries if exist, duplicate records. So EDA helps us clean and trust our data. Next is improving the model accuracy. EDA helps us select the right variables. Not all variables are useful. Some variables have strong relationship with default. This means better input means better model. Next is preventing the financial loss. If EDA is not done properly, then what will happen? Risky customers may be approved, safe customers may be rejected, and due to that, there would be loss of money, bad business decisions. So, EDA is not just a technical step, it directly impacts business decisions and profitability. Think of EDA like checking the background of a person before giving them a loan. If you skip checking, high risk, and if you check properly, this means better decisions. Now that we understand what EDA is and why is it important, let's see overall where exactly it fits in the overall modeling process. So first is the raw data. Everything starts with raw data. Data from banks, bureaus, transactions. It is usually messy, unclean, and unstructured. At this stage, data is not ready for modeling. Next is EDA. EDA is the first step where we actually start understanding the data. Here we check the quality of the data, we understand the variables and try to find the patterns. So basically, EDA converts raw data into meaningful insights. Next is feature engineering. Once we understand the data, we start transforming it. Here we create new variables, do binning, grouping if necessary, prepare the variables for modeling. So EDA tells us what to transform and why. Next is model building. Now we build the model using selected features. Here we predict the default probability and use statistical or ML models. Model quality depends on earlier steps and especially EDA. Last is the validation. We finally check whether the model is reliable. Here we assess the performance and the stability of the model and its business relevance. So if EDA is weak, everything after that will be weak. Wrong understanding of data means wrong features estimation and wrong model building. Many candidates think EDA is optional or a small step, but actually it derives the entire modeling process. So EDA is not just a step, it is the foundation on which the entire credit risk model is built. So in credit risk modeling, we don't work with just one type of data. We use multiple types of data to understand a customer's risk profile. Each type of data gives us a different view of the customer, and when we combine all of them, we get a complete risk assessment. So first is the demographic data. Demographic data tells us who the customer is. For example, age, income, employment status, marital status. This data helps us understand the customer's background and financial stability. For example, low income meaning higher risk, unstable job mean higher probability of default. Next is behavioral data. Behavioral data tells us how the customer has behaved in the past. For example, repayment history, EMI delays, past defaults. Past behavior is one of the strongest predictors of future default. So if a customer has delayed the payment before, there is a higher chance that they may do it again. Next is bureau data. Bureau data comes from credit bureaus like CIBIL. For example, credit score, number of loans, credit utilization, credit history length. This data gives us a consolidated view of customers' credit activity across all lenders. Banks heavily rely on bureau data for decision making. Next is transactional data. This data tells us how the customer is currently managing their money. For example, bank transactions, spending patterns, account balance trends. It gives real-time behavior of the customer. No single data type is enough. We need all types together to assess accurately the credit risk. Many candidates only mention demographic data, which is not enough. Interviewers expect you to know all major data sources. Different data types together create a 360-degree view of customer risk. Now let's understand what exactly we are trying to achieve when we perform EDA. So as EDA is not the random analysis, it has clear objectives that guide our entire modeling process. So for this, we understand the data structure. First, we need to understand how the data is organized, such as the number of rows where we have the customer details, number of columns where we have features, and the type of variable. So if you don't understand your data structure, you cannot analyze it properly. Next is you need to detect the missing values. In real world credit data, missing values are very common. So some customers may not have income info, some fields may be blank. Missing data is not just a problem, sometimes it gives us information. For example, no credit history. This may be meaning that the customer is new and hence it leads to higher risk. Next is identify the outliers. Outliers are extreme values in the data. So, for example, very high income or very low age can be possible in the data. Outliers can distort the analysis and mislead the model. Next is analyze the variable distribution. We study how values are spread across a variable. So, we do need to check whether the distribution is normal or skewed. This is important because it helps us understand if the data is realistic and usable. Next is to understand the relationship with the target, that is our default. We analyze how each variable is related to default. For example, checking the relationship of income versus default or the credit score versus default. So, if a variable has no relationship with default, it is not useful for modeling. So, EDA helps us understand what data we have, how clean it is, and how useful it is for predicting the default. Candidates often list objectives but fail to explain why they matter. Always connect to the modeling. These objectives ensure that we move into modeling with clean, meaningful, and relevant data. So now let's understand. There are few steps, and now let's understand that. The first and the most important step in EDA is to understand the data and check its quality. So before doing any analysis, we need to answer two basic questions. What does the data mean, and can we trust this data? So step 1 is data understanding. Data understanding means knowing what each variable represents. We also check how many customers are there in rows, how many variables are there in columns, and what type of data are we dealing with. So every row represents a customer, every column represents a feature. For example, age. It represents the customer age. Income represents the earning capacity of the customer. Loan amount, which means the exposure. So we also check the types, whether the data and the variables that we have are numerical or the categorical. So if you don't understand your variables, you cannot build a meaningful model. Next step is data quality check. Once we understand the data, the next step is to check its quality. So first is missing values. Some fields may be empty or unavailable. Incorrect values can happen. Sometimes data may be wrong or unrealistic. Duplicate records. Same customer appearing multiple times. So, for example, there can be a chance that the income is missing, credit score is missing, and too many missing values can reduce the model reliability. For incorrect values, there can be a chance that age is 200 and it shows the negative income. So these errors must be identified before modeling. And duplicate records can bias the model and distort the results. So understanding tells us what data means and quality check tells us whether we can trust it. Many candidates jump directly into analysis without understanding the variables. This leads to wrong conclusions. So before analyzing the patterns, we must first understand and trust the data. Now, once we understand the data and ensure its quality, the next step is to analyze the data. We start simple by analyzing one variable at a time and then move towards understanding the relationship. So, next step is univariate analysis. This means studying one variable at a time. So, here what do we check? We check the distribution of values and we check the range, min max range and skewness. So for example, how is income distributed and what is the age spread of the customers? Univariate analysis helps us understand the nature of each variable individually. We do get to know, is the data realistic? Is it skewed? Are there any unusual values? Bivariate analysis. After understanding the individual variables, the next question is to see how they relate to default. So, bivariate analysis means studying the relationship between a variable and a target variable. The key question arises, does this variable help in predicting the risk? So, for example, we do check the relationship with the income versus default, age versus default, and credit score versus default. So, the insight that we can draw from these relationships is that low income can lead to higher default, and low credit risk or low credit score leads to higher risk. So, bivariate analysis tells us which variables are actually useful for modeling, and univariate tells us about the variable itself. Many candidates stop at univariate analysis and don't check relationship with the target, which is critical in credit risk. So we first understand the variables individually and then identify which one actually derives the default. Now that we have understand the individual variables and their relationship with the default, now let's go one step deeper. In real life, a customer's risk is not determined by one variable. It is influenced by multiple factors. There comes the multivariate analysis. This means studying multiple variables together and their combined effect on default. This is required because in real life the variables don't act alone. So, for example, a young customer with low income leads to high risk, but a young customer with high income leads to lower risk. So, same variables can behave differently when combined with others. So, what do we learn from here? We learn that there can be interaction between variables. You need to combine the risk patterns for better segmentation of the customers. So, multivariate analysis helps us capture real world complexity. Next is understanding the target variable. In credit risk modeling, the target variable is usually default. 1 meaning the customer defaulted, meaning the customer is bad, and 0 means customer did not default, mean that the customer is good. This is the variable we are trying to predict, and everything in EDA revolves around this. In most data sets, non-default customers are very high and default customers are very low. For example, 95% good, 5% is bad. This imbalance can affect the model performance if not handled properly. So, if you don't understand your target variable, you cannot build a correct model. So, target variable tells us what are we predicting. Multivariate analysis helps us understand how multiple factors together influence that prediction. Many candidates only look at variables and ignore the interactions. This leads to weak modeling. So, understanding the target gives the direction, and multivariate analysis gives depth to our assessment. In real world credit risk data, the biggest challenge is not just the analysis, it is handling the imperfect data. EDA is not just about understanding the data, but also identifying and handling data issues that can affect the model. So, first is the class imbalance. Class imbalance means that number of defaults and non-default customers are not always equal. In most datasets, 95% customers are non-default and only 5% customers are default. So why this is a problem? This is because the model may learn to predict non-default for everyone and still show high accuracy. but in reality, it fails to identify the risky customers. Next is the outlier detection. So, outliers are extreme or unusual values in the data. For example, very high income or very low or unrealistic high age. Why this is a problem? As we discussed, they can distort the averages and mislead the model. They can make normal customers look risky or vice versa. So, outliers can silently damage the model performance if ignored. Missing values handling. These values are fields where data is not available. So, for example, income is not reported, credit history is missing. And why this missing value part is important? Because it is very common in credit risk. Sometimes missing itself is meaningful. Like we discussed, no credit history means new customer and higher uncertainty it holds. So, missing data is not always a problem, sometimes it is a signal. So, these three issues, imbalance, outliers, and missing values, directly affect the model accuracy and business impact. Many candidates identify these issues but don't explain their impact on modeling. Always connect to the business impact, and handling these challenges properly is what makes a credit risk model more robust and reliable. After understanding the data and handling the challenges, the next step is to focus on what really matters. Selecting the right features and avoiding common mistakes. So, EDA is not just about analyzing the data, it is about identifying which variables actually help in predicting the risk. So, there comes the topic the feature relevance. This means identifying which variables are useful for predicting the default. Not all variables in the dataset will help in modeling. So, for each variable, we should ask, does this help in predicting the default? This is important because including the irrelevant variables can reduce the model performance, adds the noise, and make the model unstable. Good models are built on meaningful features, not on maximum features. Now let's talk about the mistakes that many candidates make during the EDA. First is ignoring the missing values. Not checking missing data properly can lead to wrong conclusions. Next is not checking the distributions. If you don't understand how data is spread, you may misinterpret the variables. Ignoring the business logic. EDA is not just technical, it must make business sense. For example, a variable may look important statistically but may not make sense in real world lending. Over relying on visuals. Graphs are helpful, but blindly trusting them without thinking is a mistake. So EDA is about thinking, but not just plotting. EDA is effective only when we focus on meaningful variables and avoid common analytical mistakes. Most candidates focus on doing EDA, but very few focus on doing it properly. So, success in EDA comes from selecting the right features and avoiding the common pitfalls. Now, the most important part, how EDA is actually asked in interviews. Interviewers are not just checking whether you can plot graphs, they are checking how you think. What interviewer is actually looking for? Clear understanding. They expect you to clearly explain what EDA is, not just the definition but also the purpose. Can you explain it in a simple language is what they are trying to see. Logical thinking. They want to see your approach. First, you need to understand the data, then check its quality and then analyze the variables. Lastly, study the relationship with the target. Your process matters more than the tools. Next is business interpretation. This is very important. This is where most candidates fail. You need to explain that it is not enough to say that income is low. You must say low income customers have high probability of default. So you always need to connect the data with the risk. Lastly, you should have the ability to explain the insights. Like, can you explain what you observed? For example, if you can rightly explain which variables are important and due to that, which customers you find out that they are risky, then it makes an impact. So, EDA is about storytelling with the data. So, EDA is the first step in credit risk modeling, where we understand the data, check its quality, analyze the variable distributions, and study the relationship with the target variable. It helps in identifying important features and deriving the business insights for better risk prediction. In interviews, EDA is not just about tools, it is about thinking, logic, and business understanding. Candidates focus too much on technical terms and forget to explain the why behind EDA. So, to crack interviews, focus on clarity, logic, and business understanding, and not just the technical steps. Now, let's quickly summarize everything what we have learned about EDA in credit risk modeling. So, EDA is not just a step, it is the foundation of the entire modeling process. Every strong model starts with EDA, as EDA is the foundation. If your EDA is weak, your model will also be weak. EDA helps understand the data. How? It helps us understand what data we have, whether it is clean or not, whether it is reliable. Without understanding the data, modeling is just guesswork. It helps to identify the risk patterns. EDA helps us discover patterns like which customers are risky, which variables impact default. This is where real business understanding comes in. EDA also helps in improving the model performance. By selecting the right variables and handling the data issues, EDA improves the accuracy, stability, and reliability of the model. EDA transforms the raw data into meaningful insights that derive the better credit decisions. Many people treat EDA as a small step, but in reality, it is the most critical step. So always remember, a good credit risk model starts with strong EDA. So if you found this video helpful so far, please make sure to like this video. And if you are preparing for credit risk modeling or interviews, don't forget to subscribe to my channel because I will be sharing more detailed and practical content like this. Your support really motivates me to create more such high quality videos. And also, do share this video with anyone who is preparing for credit risk interviews. It might really help them. So far, we have understood EDA from a theoretical perspective. Now, let's take it one step further and see how EDA is actually performed in Python so that you get better clarity and real world understanding. So make sure you stay with me till the end of this video because in the next part, you will see how everything we discussed is applied in practice. Okay, so now let's get started with the Python implementation to understand EDA. So I'll first import the libraries, basic libraries if required. I'll now see if any what exactly is my current directory from where I do have to pick my dataset. Okay, now I'll define the data path. So for this I'll copy from above. Okay, now my file is in txt format. So for this the syntax I'll change a bit to read the file. And since once this command reads the file, I want to see few lines like how my data set looks like. So for this I'll do the for loop, and I'll then print those lines. F dot read line. So here you can see that there is little bit of jargon like detailed data description of credit risk data set, some feature name, person, etc., 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 loan status, perceptions, and some jargon related to that data set. And from here you see below this @data, my actual data is getting started. So we need to skip those lines to understand how exactly my data set is. So for that, what I'll do is I'll read a command dot read under CSV, then data path, and then my data set dot txt, and then there is a command called skip rows which will allow me to skip the rows. So I'll do 75 data. So here you can see my all the rows being skipped now. The first row, if you can see 22, 59,000 and so, although it is getting started from the header, the column heading skip, at least, but at least we do have skipped the above jargon. Now let's handle this, the column name, because eventually this 22 should come at the 0th level. So we need to convert the current columns into a row. So convert current columns to row. So for that we'll do data.log. We'll all have gone through the basic log, ilog and everything. If you haven't already, then you can check my playlist, and there are many Python videos there which talks about the basic. So we'll convert the columns into row. Then we'll do the shifting of the index. Shift the index. For this, how we'll do data dot index is equal to, we'll say that makes it index plus 1, and then we'll then sort the index. So for that we have a command, you all know everything, it's sort underscore index. Now let's see the data by printing the head. So you can see that 22, 59,000 or so, there it has been in the rows as well. Now the task is to change the column names only. We do have the data now. So for that we'll do data dot columns equal to, first column would be, let's say, person age. Next column you can see that it is person income. Third column is talking about whether it is homeowner, rent, own, mortgage and everything. So it's person, I will say home ownership. Then the fourth column is talking about the person employment length. Person, all right, yes. Next is whether what exactly is the intent of the loan, for what purpose he is exactly taking the loan, be it personal, education, medical or so. So we'll name this column as person intent. All right. Next is loan grade. I would say not the person intent, I would say it is the loan intent. Then once we are done with the loan intent, the loan grade, then how much amount that loan is for. Loan amount. Next is the loan interest rate. What would be next? Next is loan status. Loan status. Next would be loan personal income. Next would be whether person is getting default or not. Person underscore default. And last would be what exactly is its credit historical length. Now let's see how our data set looks like. So now we do have columns with all our rows. We do have now. So now let's see what exactly is the target variable. Let's understand the target. All right. So for that, we'll see the column called this one, how the person default or not, and this is exactly our target variable in this person underscore default. And to see its status, we will do value counts. So it's showing that only 5,745 is the default count. So let's normalize this and see in percentage what exactly it's look like. So for that, you need to, in the value counts command, you need to normalize equal to true. Okay, so 17% is the default and 82% is not default. So that's basically shows a bit of class imbalance as well. So now let's understand the data. So the first step is to understand the data. Whatever we are doing, we'll do it all together. Although it will take a bit time, but it will create a good understanding for everybody. So our first is to understand the structure. Okay, so for structure, what do we need to see first? The first and foremost command should be the information regarding our data set. So there are 32,581 entries, and out of that 12 are columns, and these are the column names, right? And what exactly is your data shape? This is your data shape having this many number of rows and then the column count. Next is data.describe. So for numerical columns and the categorical columns as well, this will show the count, the unique, top, and frequency. Now once you have noticed that the columns are, the data type of the columns is the object data type. So we need to convert this into numerical ones as well. You can see that separately as well, but exactly is the data type. So everybody is in the object format. So we'll then we need to convert the data types as well, and that these small things are part of EDA. So we'll first figure out the numerical columns. So first of all, if you see, this person age is numerical, then person income, then person income, after that person income, the person home ownership. The spelling is wrong, ownership. Let's correct it. Person home ownership. Now is okay. Person home ownership is my next numerical column. Next, we have person employment length. Next is loan intent. Is loan intent come into that? No. So next is my loan grade, no, loan amount. Next is loan interest rate. After loan interest rate, loan personal income, and then last column, the credit history length. Okay. So these are my numerical columns that I have defined, and I need to convert them into from object to numeric. So for that, we'll see for we'll run a for loop, and in that we'll say for each call that is lying in the numerical calls, convert it into numeric. Here we'll mention the errors equal to coerce. I'll pronounce it as coerce, COERCE. So you might be wondering why this is done. This is done so if any value is like capital NA or missing is in the dataset, it automatically becomes NAN instead of breaking the code. Okay, so now let's check once again what are the data types. So now you can see for the columns that we defined, we have defined the data types. So that's the first part of the EDA. Now let's handle the missing values. Okay, so for that we already have done this in our previous Python classes. But for this we'll do data.isNull.sum, and it is showing that home ownership, employment length, and everything have why it is showing person home ownership has no data. Give me a second. Home ownership has is categorical. Person home ownership is categorical. So this should not be first of all in the numerical columns. Person age, person income, employment length, loan amount, interest rate, income, and historical length. Okay, let me run the data once again. Uh, yes. home ownership has become object. Yes, so home ownership has no null values, and employment length and interest rate have few missing values. So there can be, I mean, your way of imputing can be by mean or median or so. What I am doing is right now the imputation in the numerical call uh, through median. So for that we'll use the command fill na, and then we already have discussed in our previous Python classes, and then I'll replace it through median. Okay, let's check once again the status of missingness. So now it has become 0. Replacing it by median is my personal choice. You can change it accordingly. Next comes, so our 1.2 is handling missing values. Like we discussed in our previous discussion, that we'll now do the univariate analysis. So I am discussing the few steps of EDA. Univariate analysis means one variable at a time. So for this, let's pick up a variable called person income. We do have that variable person income, and let's see if we can figure out something from that variable. So for that, data of person income dot describe. We'll first see what exactly is this variable. Since it's a numeric variable, you can see that it is showing count, mean, median, standard deviation. Maximum value is 6 into 10 to the power 6 and so on, standard deviation like that. So now let's plot and see how exactly is this variable look like, because we are talking about person income. So to plot this, we'll import the library matplotlib. Plt notice some income. Okay, so you will see a histogram that, and it is showing that the maximum range is above 30,000. And we can do see for a categorical variable as well. So this is for the numerical variable, as person income is numerical. So by plotting the histogram, we see that what's exactly is its maximum range, and from this to 25 and 50% and 75% quartile. Similarly, we can do this for categorical variable as well. So let's pick up a categorical variable, loan intent. Let's pick up that. So loan intent, for that we'll first, since it's a categorical variable, for this we'll do value counts to understand the different category counts. So different categories are for taking the loan are the education, medical, venture, personal, debt consolidation, home improvement. So I'll see that this particular data shows what exactly the loan purposes are in common for a person, and also certain loan intents like personal loan may have higher risk because it's kind of an unsecured loan. Okay, so that is one an example. You can see for other variables as well. Now let's do the next point in our EDA, that is the outlier analysis. Okay, so we do have a variable called loan amount. Let's figure out if any outliers is there or not. So PL will plot box plot for this data. Okay, so can anyone figure it out? But exactly is this box plot trying to tell us? So the box plot is telling us that the distribution, the median orange line is kind of a center for this distribution. It coming around 7,000 or something is, if you look at it, that it is the most customers are taking loans around this range. And if you look at the spreads also, that the lower bottom is coming out around 5,000 and the upper one is coming at around 12,000 something. So my spread would become, the IQR spread would be 12,000 minus 5,000. So that is, this is my Q1 quartile and this is my Q3 percentile. And 50% of the customers lie between this range. So you can look at the definition for the IQR. And very important with respect to these outliers, these are the outliers and it shows us that a strong right skewness. You can clearly see a long upper tail and many points are above the whisker. So loan amount is positively skewed. That's the beauty of doing the ADA. We get to know that this variable is positively skewed and few customers are taking very high loan. This is the loan amount and very few customers are taking high loan as well. So many outliers, if you see, this would be around 22 or 23, roughly around that. So many outliers are above this value and some are going 35,000 plus as well. So these high loan amounts represent risky customers as they are taking high loan amount and they do have high exposure of the loan amount, and this will increase the probability of default. So what I'm trying to tell you here is that the outlier analysis is a very important concept as it gives insight related to a PD. And from the business insight, this is very important from your interviews point of view as well, that customers with high loan amount, they do have high financial burden and high default risk chances as well, and this variable is very important for modeling. So interviewer can ask you, what should you do with the outliers? So you can also say that you are keeping them as recommended, and because these represent the risky behavior, and you will see it with another variable how exactly it is behaving, and you cannot take any standalone decision. Or you can cap them as well, the very famous thing called Windsorization. So first point is that from the outlier's perspective, that you are keeping them, you keep them as it is and will figure it out with other variables. Or option 2 is to do Windsor, that is capping. How exactly you can do? You can do it like, first you need to call, so first you need to call the variable loan amount, and then you are clipping the upper data as the outliers are in the upper range, so you will be clipping that data, and then you need to define the quartile. quantile. 99% quantile also is what you need to define, and then it will clip. I'm not running as of now, but this will clip the data because I do need this in the upcoming analysis. So that's how you can do, right? So if interviewer asks you, what will you do with the outlier, or what will you do with this skewed variable, what will you say? You can say, I can keep it if business meaningful, or I can do binning also if, in the future, or I'll do log transformation as well. So one needs to figure out. So you can see that only one variable, the outlier analysis, that's the part of exploratory data analysis, that you need to see each variable, you need to understand it, each variable, what exactly it is trying to represent. Since you are working on one variable only, so that means that it is a univariate analysis. But when two variables comes into picture, and most importantly the other variable should be the target variable, so with respect to each variable, you, when you are trying to figure out its relationship with the target variable, then it means that you are doing the bivariate analysis. Most students, most interviewers, they do get confused. The candidates do get confused here. They initially assume that bivariate means understanding the two variables together, but that's wrong picture. In this, one variable should be target, and every variable relationship should be determined with the target variable. So first we'll do the numerical versus target. Okay, so for this, let's take a variable called person default. Person default is my target variable, and since we are figuring out for the loan amount, let's understand how exactly it is coming out, for with its relation is coming out with the target variable. So for this, I'll run a group by command where I'll check how the person default is behaving with the loan amount. And for that, I'll take the mean to understand the relationship. So the key observation is that the defaulters have high average loan amount. So here we are understanding the default relationship with the loan amount. So the defaulters, the Y stands for the defaulters, and they do have average high loan amount. So customers who default, they do take larger loans on average. So that's the insight from that. So customers who default, that's the observation that I am getting from above, that they take larger loans on average, and which is less in with comparison to the non-defaulters. So customers who have taken higher loan amounts are more likely to default. That's the observation that we can find it out. And from the risk perspective as well, if loan amount increases, this means the risk is also increasing, and exposure increases. This means the probability of default increases. Higher the loan amount means higher the exposure. Higher the exposure means higher the chances of PD, and that exactly is the direct risk driver. However, this is just an average comparison since we do have taken mean. We should also analyze the distribution and control for income as well, because high loan may not be risky if income is also high. So if a person has high income, and let's say that person has taken high loan amount, so we do consider that as non-risky, because that loan, that his income itself is bearable, he can manage to pay the EMIs on time. So we'll first see, we'll draw a plot, and let's understand how exactly it is looking from a visual point of view. So for this, I'm importing a C1 library, and then I am doing a box plot again. Box plot, in this my x-axis is person default, which my y is loan amount. You can take the syntax from the code. Let's see if graph comes up. Okay, so for the person who have defaulted and for the person who have not defaulted, we are observing its relationship with the loan amount. Like we said, the person who do have defaulted has high exposure to loan amount, right? So now let's understand if income is something that we can, if we can figure out something from income also. Loan amount, we do have see a relationship from here and from the visualization as well. Now let's bring income into picture as well. Let's create a variable loan to income. So we'll I think, yes, loan to income. So for this we'll use loan amount, and this is getting divided by the person income. Income. Now we will establish the relationship similar to this with the new variable that we created, and this is also a part of bivariate analysis where we need to see now this loan to income variable relationship with the person default. Okay, so now from here we do see that the person who do have defaulted has high loan to income 17.9%, and from the box plot we do see that both the defaulters and the non-defaulters, they do have similar median. If you see the median, the black line in the middle is approximately equal to 8,000 or so for both the defaulters and the non-defaulters, and if you calculate the spread as well, if you do calculate, that will also come out to be similar. And outliers also exist as well for both the plots. So the loan amount itself is not a standalone strong discriminator. Even though earlier the mean was showing a lot of difference, where that point is. So with respect to loan amount, we do see that the standalone that the defaulters have taken high amount of loan. But when we are plotting it with respect to the default and looking at both the pictures separately, so both have different set of their own outliers, and box plot shows heavy overlap. So although average loan amount was slightly higher for defaulters like we have seen, the distribution of both the groups overlap significantly, and this means that loan amount alone cannot clearly separate the defaulters from the non-defaulters. That's why we calculated a variable called loan to income, and we do a bivariate with the person default, that is the target variable, and we do see that the defaulters have higher loan burden relative to its income. That's the beauty of this loan to income variable with respect to the variable loan, how exactly the income portion, and this is much stronger than the loan amount alone. So high loan is not always risky, but high loan relative to its income is risky. So when we normalize the loan amount by income, we clearly see a pattern that defaulters do have high loan to income ratio, and this means that the repayment burden is more important risk driver than the absolute loan impact. So are you able to see that with respect to only very few commands and syntaxes, we are able to drive so many beautiful picture. So for income comparison, banks always try to figure out with respect to his income, how much exactly the loan he has taken. So you should not rely only on the loan amount, but definitely include this loan to income ratio, and we will use this further in our WA transformation as well. So if in interview it is asked which variable is better, the loan amount or the loan to income, what will you say? You should say that loan to income is more predictive because it captures the repayment capacity, and which is a better key driver for understanding the default risks. And we can further do binning and WA on this variable loan to income to understand what exactly is the insight with respect to the relationship with the target variable. And this will be our next core concept for our upcoming class. This you can do for categorical variable as well. One can plot a cross tab. So let's look at the categorical variable as well quickly. Categorical variable. So one categorical variable, we can pick it up like loan grade. Let's pick up loan grade. Loan grade variables are like, yes, A, B, C, D, capital and small. So let's quickly see the picture behind this variable. Cross tab, we'll plot a cross tab between the loan. So here what exactly we are doing? We are doing a bivariate analysis on the categorical variable. So in bivariate analysis, this is important that the other variable should be the target variable. And our target variable is person default. And I'll also put normalize equal to true so that the scaling becomes same. Index. That's the command for normalize. Let's see. Yes. So this shows the default rate across different grades. And for A and B, the percentage of non-defaulters is good and defaulters is not present. For the grade G, you can see that the highest default is with respect to the grade G. So you can do this kind of analysis for other variables as well. Now let's quickly see. One can do correlation analysis as well to understand the relationship between two variables. Okay, so we do have studied this in our previous Python classes, that it is done for the numerical variables. Also, the command is very simple. So you do get a cross tab kind of a matrix where you see that the variable with itself has 100% of correlation with them, but with respect to other variables, you can see that with respect to this diagonal, the upper values are reciprocal of the, you can see not reciprocal, I would say the picture is same. Either you see upper half or either you see the lower half. So let's quickly go through what exactly is the correlation analysis. Okay, so here most correlations are low to moderate. You can see very low values to medium values, and high correlation, if you see that person age with respect to the credit history length is has the highest correlation. And this does mean that the older people do have longer credit history. And I think this is logical too, that older people do have logical credit history. So we observe that a high correlation between age and credit history. The age, and you can see in the bottom as well, the person age with respect to the credit history length do have high correlation because they typically have longer credit histories. They are stable comparatively, and however including both the variables in the model, but if we do include both the variables in the model, this may lead to multicollinearity. So for that we need to choose one, and we'll, let's say, keep credit history length, which is more predictive, and we do have seen in our working life as well. And moderate correlation is something like around 50% or so. Is there any variable? Let's find it out, if any moderate correlation variable, if we can find it out. So loan amount with respect to personal income, it has 57% of moderate correlation, meaning the person with higher income, personal income, they can take higher loans because loan amount is with respect to, and this is also logical. So we see a moderate positive relationship between loan amount and income, because higher the personal income, it is chances that the person can take for loan amount, high loan amount. And this is not a risk, this is just a behavior. And weak correlations are there, which is a good sign that most correlation variables have, most correlation is less than 0.3, and which is good, which means that each variable brings a unique information and we don't need to drop any of it. Okay, so interviewer asks you, what will you do if two variables are highly correlated? What will you say? You will say that you will drop one out of two by checking its business relevance, and you will use VIF if needed. We'll see VIF in the future class. Don't worry about that. Okay, let's quickly plot the heat map as well to understand the correlation analysis, and after this we'll see in our next class. Okay, so to plot the heat map, do you know how to plot that heat map? So it is coming from the Seaborn library, heat map for the numerical columns. And annotation is true. Okay, this is coming out to be very beautiful. Same representation of correlation analysis, just in a pictorial way. So this shows the correlation between the numerical variables, and values range from -1 to 1. You can clearly see from negatives to positives. And the light color, which is towards the white cream or so, shows the strong positive correlation. You can see that strong positive correlation. And dark color, which is purple or black or purple, shows the negative correlation. And the medium shades shows the weak correlation. All right, and whatever the insights are, they are whatever we have discussed with respect to the person age, credit history length, loan amount or so, can be visualized from this as well. So I request you to pause this video and try to match and try to make inferences similar to above from this heat map as well. Which variables are causing multicollinearity, which variables do have weak correlation also, you need to figure it out from the heat map as well. And if interviewer asks you, why do we check correlation? So this is done to detect the multicollinearity, that is to remove the noise from the data, to remove the redundant variables, and to improve the model interpretability. So, but correlation only shows the linear relationship. And for credit risk modeling, we do rely more on WOE and IV for our analysis for better feature selection. So we'll not stop here. In next class, we'll do a dig deep further using the WOE IV analysis, and then we get the model building as well. So in real world credit datasets, many numerical columns come as text due to file formats. So before doing any analysis, we must first convert this into numeric data types that we have seen in our video, and otherwise all calculations will fail. So EDA is not just about graphs, not just about the plots that we do have done, but it is all about selecting the features, create new variables, and also figuring out the what exactly the picture this variable is trying to tell us. This can be done, the above analysis also can be done with other variables as well. And be a storyteller, not just that jargon story, but a meaningful story for each variable with respect to its default, its relationship with the default. So after correlation, we'll in our next class we'll move to feature selection for modeling. We'll do binning, WOE calculation, and IV analysis as well, and we'll understand each and every concept in detail. So if you found this video helpful, subscribe to my channel, and in the next video I'll show how to build a full credit risk scorecard using WOE IV and with our very first model, the logistic regression model. So I'll see you in the next video. Stay tuned to my channel and hit the like icon and subscribe to my channel.